Okay, now we're going to place parts. So normally most of the parts that you need are available here in the common library. So you can see there's resistors, capacitors, inductors, then batteries, terminal blocks, headers, and so on. Alright, so far so good. So I'm going to just show you how to make a very simple circuit. So I'll just make, let's say, an LED circuit. So with a sort of resistor divider. So let's say I want, so I can just choose a part. So what's important here is we need to know what the footprint of a part is, because our intention is to make a PCB. So at the end of the day, we want to see its footprint. So we need to know what kind of component we need. So we want an axial resistor. Alright, so what this means is an axial resistor means that it has two leads coming out from its axes, as opposed to any radial component for example, a capacitor. It can be a radial component as well. So radial component means that both of its legs are on the same side, like an LED or electrolytic or ceramic capacitor. So I do want this to be the case, that I want through hole components. So we can look at the difference between the two. So these are all SMD components, so surface mounted devices. So I can give you an idea. So notice that if I select the part, the model number here, it changes. So if I place this component and if I place this component, and I can then compare between the two. So let's look at R1. Let's compare their footprints. So let's look at this component. So notice the footprint. It shows you that there are only two pads, and this is the outline for the component. So let's look at its size. According to this footprint, it's only like less than half a millimeter long. The distance between the center of the pads, right? So the resistor must be smaller than this pad, all right? So it will sort of fit between here. And I know for a fact that all of my resistors are bigger than this. All of them are through hole components. And notice that this part doesn't have any holes in it, right? This is just a pad on the top layer. So I can't use this part because my intention is to make a different kind of resistor. I want to use a through hole component. So let's look at this one. Yeah, this one. So I go again into custom properties and I look at its footprint. I think I selected the same part. I want to compare a different one. My bad. Let's just delete this one. I want the axial one. Yes. Is it the axial one? Yes. So now notice that this footprint is very different. This footprint shows that I have multi-layer pads with holes in them, and the component outline looks similar to the one I have for my resistor. It's approximately 7.5 millimeters long, which is more than enough for the resistors I have in my lab. So that's great. So I'm going to use this part instead of this because it's a through hole component. Alright, so now what other component do I need? I need a terminal block. So I'm going to search for one here. Let's see if we find one. I doubt it. Yeah, so no terminal block. Nothing like that. Okay, so that's great. That will give us a good idea. So let's look for an LED actually. Yeah. Okay, so we have an LED. In the list, so again, these are all surface mounted, and normally through hole devices would have TH written on them, or axial or radial, you know. So I want to look for something like this. I have a 5 millimeter LED which is red in color, so I'm going to use this one, and I'm just going to place it close to my resistor. And just to confirm that we've gotten the correct component, it's best to always look at the footprint. Yeah, this looks good. So 2.5 millimeters, that seems about right, but you will be measuring the distance in the lab using vernier calipers, so you'll know, okay, is this enough or not. So also, even if it's not exactly this, it's fine, because we can also always bend the the pins, but make sure it's not too much. All right. Then we need a terminal block. Okay, so for the terminal block, I'm gonna go into the library. So I didn't go into the common library, I went to the library. Alright, I'm gonna now search for my terminal block. Terminal block. Alright, now notice that there are a couple of classes I can look into. I found that this class almost exclusively has surface mount components, and system might be able to help. You might get uh, good parts in system, but you'll always get a part in the user contributed once, but it's difficult to search in this one. So let's start with system and look for a 2-pin. Yeah, oh, good luck. So good for us. I think this one seems right. So on the right hand pane, you will always see sort of like a footprint and a schematic symbol, both. Now I want to make sure the schematic symbol is appropriate for the job. So this one seems appropriate, and I also want to see the footprint. So we won't know actually if the footprint is the correct one until we actually place it, you know. So we can look at a couple of footprints and see, okay, so this was a 3-pin terminal block. We don't need a 3-pin, we need a 2-pin one. I feel like both of these should suffice. They're exactly the same. And if you want other ones, you can also get them. I think ours is a 5 mm terminal block. This would also work, but I feel like its outline is bigger. So I think this one is the best one. Okay, so I'm gonna hit place to get that component. Now notice its leads are on the other side, so I wanna actually move it this way. Alright, and sort of bring it close to where I want it. Alright, so I feel like I have all my parts ready. Now I just have to assemble them, move them around. If you want, you can just delete this, the labels that you don't need. Now you're just gonna press W to bring up the wiring tool. So W brings up the wiring tool. You can see there's a crosshatch that you can use, grid lines that help you navigate to a node. So now you can connect one of the ends of this terminal of a resistor into the terminal block. So yeah, so that means that this must be my VCC because the LED is biased, positively biased this way. And then you're gonna go and connect the LED to the ground terminal. Then, okay, so now I can also move things around. I can rotate objects if I like. So I pressed R to rotate it. You can also use this pane. So you can rotate devices this way as well. You can flip them like this. You can align them horizontally or vertically. You can align two objects. So for example, if I want to align these two vertically, I can align them this way. If I want to align them horizontally, I can align them this way. Alright. So these alignment tools are very useful. But make sure you align them before you wire them, so that you don't go into trouble like I am right now of rewiring them. So I can wire them this way. Also I can move my wires around once they have been wired. So like, you know, this way or this way, you know. And then I bring up the wiring tool again because I need to wire it again now. Yeah, and that should be good enough. Alright. So now what we're going to do is we're going to give a VCC and ground. So I was supposed to make a resistor divider, but that's alright. I feel like this should be 150 ohms. You don't necessarily need to write this, but it might be useful when you're making a PCB. So if I just click on the component, go into its text properties, component properties, you can see that it is name. But if I just click on the text, you can see the text itself shows text properties. So I can change this, and so on. If we want to place more text items, or you can place more text items, so I can just change this like PCB or PCB LED, and it changes it this way. Alright, so these floating toolbars are also useful for, like, for example, you have the wiring tool here as well. If you want to add a net label, you can add it here. and we do need a ground flag, so we'll just use that from here, but you can also find it in the library over here. I use the wiring tool now to connect my ground terminal to my ground and my VCC. So I also need a VCC here. If you know the voltage, you can use the 5 volt flag. I have calculated it for 5 volts that this is 150 ohms, but I'll just use VCC just to be sure. If you have multiple power rails, then it would be wiser to use the 5 volt or 9 volt or 20 volts depending on what your requirements are. Alright, now we're going to save this schematic, and you can also check for nets, I believe. Yes. Yeah. So this tells you what kind of wires you got here. Alright. So these are your nets, the connections that you have. Some nets might not be connected, so it will show you, okay, this net isn't connected. Do you want to connect it? So it will prompt you to do that.